Hi everyone, nice to meet you and good afternoon. Kerr Johnstone from i3 Solutions and my colleague Joe Sheehan, also from i3.
Hi everyone.
So just a little bit about i3 just to begin with. i3 Solutions, we're a consulting engineering firm. We have offices in Glasgow, London, Singapore and just recently in Indonesia as well. In terms of i3, we are solely dedicated to the data centre and mission critical market. We don't do anything other than anything to do with mission critical facilities. So in terms of what we do, we cover design, anything through from concept design through to detailed design. We also have a consulting part to the business where we provide expert witness on certain types of failures that may happen in the industry, and we've been called in to provide that service. We also provide on-site support in terms of site commissioning, client representative roles and resident engineer positions if so required by our clients. And another aspect to the business is our analysis. We're really keen on establishing how reliable systems are from an MEP perspective. So we do reliability analysis of MEP systems to determine what their availability is. And we also, if we have had any failures from clients, for example, we've been involved in root cause analysis where we dig deep into what that root cause analysis of the failure was, and we can provide an insight as to how to mitigate that moving forward in the future. And then finally, we provide an advisory role where we'll do due diligence on initial site selections. We'll look at sites that maybe clients are looking to purchase. If they have purchased them, then we look at how we can maximise those sites for the clients in order to maximise their return on their investment, which is obviously key. And we also provide some risk assessment to those existing sites as well, in terms of where they have single points of failure, where they can optimise the sites, where they can improve them to ultimately sell that on to the future customers. So in terms of the main topic of this presentation is to provide you guys with an overview of the low carbon technologies from a greenhouse gas abatement. So as part of i3's what we do as a day-to-day business, we obviously do our engineering, but at the heart of it, we like to look beyond what we're doing on a day-to-day basis and look towards the future and where the industry is going and how we can help support the industry and help to drive things moving forward in terms of change. So we formed the i3 and EYP Greenhouse Gas Abatement Group to help research all of the low carbon technologies that are now coming onto the market, to help to demystify how we can practically implement all of those systems into data centres in the future. And you probably heard in the press and some of the hyperscalers all stating that by 2030 you're looking to have a net zero carbon data centre of the future. So in terms of some of the white papers that we're looking at, there's 15 white papers in total. We've released 2 of them currently that you'll have seen some maybe adverts on LinkedIn promoting those publications. But moving forward, you can see on screen there's 5 that will be coming up over the coming months. So in terms of assessment and application of gas reciprocating engines, gas turbines is included in that as also, assessment and application of fuel cells for data centres, demand response opportunities, the GHG reduction in terms of blended hydrogen and natural gas, in other words moving away from diesel, and then embodied carbon reduction. In terms of an introduction to the GHG Abatement Group, we see sustainability as both a journey and a destination. We've all been in the industry for a long time. We've seen changes. We've seen what needs to move forward and how we need to change in the future. So for data centres really to be truly sustainable, there's lots of things that the industry needs to change at this moment in time. And there's some things that we need to stop doing moving forward in order to allow that to happen. So in terms of that, obviously it requires collaboration between everyone in the industry. And for us, i3, we partnered with EYP Mission Critical, who are our partner in the US. So in order for us to give a global approach, we're looking at the whole world in terms of how we can be more sustainable from a data centre build perspective. So where are we now? In terms of government regulation, there is no hard and fast government regulation stating what we should and what we shouldn't do. But data centre owners are obviously taking action in terms of how their business is impacting climate change, which is ultimately going to start to drive what we do within the industry. But from our perspective, we do see that moving forward, governments and organisations will start to enforce certain implications on data centre providers moving forward. And you'll see here in Scotland, from a decarbonisation of the grid perspective, Scotland has pretty much closed most of its coal power plants, which provided most of the energy here in Scotland. We're now moving towards hydro, not so much nuclear, but definitely renewable energy in terms of wind, not so much in the solar side. And from previous topics that we've had at Hosting Scotland, there is a push towards some of the tidal power requirements. So in terms of renewable energy, it does bring enormous benefits, but they are intermittent. And that brings its own challenges where we have to then store that energy to be able to use it when we require it for data centres moving forward. And as I said in the previous slide, a number of the hyperscalers have made the commitment to be carbon zero moving forward towards 2030. So in terms of traditional data centre design, we all use UPSs to condition our utility power. We typically use battery storage, anything from 3 minutes to 10 minutes of autonomy, typically VRLA batteries at the moment, most of us would have come across. But moving forward, and what the progression is at the moment, is moving towards lithium-ion batteries. That isn't going to be the future. It's not sustainable. It's not the right product in our eyes from an i3 perspective, and there is newer, more emerging technologies that are going to be more sustainable that need to be considered moving forward. In terms of emergency power, we all use diesel generators currently. There's not many other options to us prior to this time. We typically had 24, 72 hours of fuel autonomy. And in terms of the diesel engines, they obviously have a high content of CO2. Particulate emissions aren't good for the environment, so we have to start to look to move away from that. So in terms of being more sustainable in the future, diesel engines aren't going to be the answer. They're not going to be able to be used for grid support, for energy storage. And when you consider countries like the UK, these generators sit there as dead assets for the majority of their life. They're used for a very few number of hours. And most hours that we typically use them for is for testing purposes. And then when you consider moving forward the next generation of data centre, will it be diesel, natural gas, or a blend of natural gas and hydrogen? That's the fundamental question, and that's what we're doing as part of the GHG Abatement group, is looking into all of these potential options moving forward to provide a more sustainable data centre. But one of the big factors in all of this is the grid emissions factor. So each country, you can see on the graph there, has a hugely different grid emissions factor. Sorry, typically. This is referred to as the carbon footprint of each of those energy sources. So that includes all the effects of the GHG emissions that are included within that number to make up that figure. So each one of these combinations has a massive influence in terms of what low carbon technology you're going to implement in a typical country. So if you take, for example, one country where it's primarily using coal as its energy source, if you change that to have gas and use gas generation as your primary source of generating power, you're going to have a huge benefit in terms of that grid emissions factor against that original coal figure. So in terms of the embedded generation, what opportunities are there for data centres, and what we'll be looking at as part of the GHG group? So one of the first things to consider is the existing diesel. There's products on the market where we can change the diesel that we're currently using to the HVO fuel. We can move towards biofuels to help in the interim, and there's also new reduced CO2 and NOx diesel that's on the market at the moment. So that's the first step in terms of becoming a bit more greener moving forward. The next stage we see is substituting those diesel engines for for lower carbon alternatives. For example, gas reciprocating engines, gas turbines potentially. Both of these obviously providing much lower NOx and SOx emissions, which then allows them to be operated as continual site generation piece of a plant, as opposed to having the dead assets of the diesel generators on site. And then moving on from that, we then start to have the opportunities where natural gas and hydrogen, etc., they can start to be mixed and used to power these engines also. And then moving on, we also have the fuel cells, solid oxide fuel cells, which obviously use the natural gas, biogas or hydrogen to power them. And then we have the H2O fuel cells. So there's many options for us to consider in the future. It doesn't have to be diesel anymore. So in terms of storing that energy that we generate, we've obviously got the typical reliable batteries. You see that we're moving away from VRLA batteries towards lithium at the moment. But as you can see on the right-hand side there in the graph, there's a number of other battery technologies out there that are emerging, and they are a lot more environmentally friendly and more sustainable than the likes of the lithium ion that we're currently using. We also have kinetic energy, compressed gas, hydro, high temperature energy storage, the gravity storage and the nanotechnology. So all of these are going to help us move towards that 2030 target of reducing the carbon footprint for data centres moving forward. So what other opportunities are there for data centres moving forward? So we talked about those diesel generators being dead assets. We now have the potential to use the gas engines, gas turbines, fuel cells in order to support the grid that we've started to decarbonise. The grid isn't quite as stable as it maybe once was. So we as an industry can start to support that. Our industry can then start to gain revenue from that to help develop things moving forward. So some of those options are the dynamics and static frequency response. We've got the short-term operating reserve. We also have demand-side balancing and demand turndown. So all of these are topics that the GHG Abatement Group are starting to research, and we will be releasing future white papers on these moving forward. I'll hand you over to Joe just to pick up on how this can affect the Scottish data centre industry.
Thanks, Kerr. So this slide is specific about Scotland. So there are significantly greater opportunities for data centres specifically located in Scotland, where there's a desire to achieve global greenhouse gas reductions. So the first key one is that the grid in Scotland has a much lower carbon intensity than any other region in the United Kingdom. So it's between 20 and 50 times lower than another UK region on a typical day. So simply placing a data centre in Scotland with the same technology and solution and PUE, you've already brought about that sort of carbon reduction factor. And the reason that carbon intensity is so low in the grid is obviously because of the abundant natural renewable resources that Scotland has successfully harnessed. And that greater portion of variable renewable energy, that presents a challenge which data centres are uniquely positioned to meet. And it relates to what Kerr was mentioning, which is the fact that data centres have assets which are typically dead or underutilised for the majority of the year, that offer energy storage and micro power generation. So those assets can be considered for redeployment with alternative technologies such as the ones we've mentioned, and combined with demand side response to support the grid, manage the fluctuations you have in supply when you're dealing with variable renewable energy. And that in turn will actually allow a greater proportion of variable renewable energy on the grid by solving that problem. And it also helps us move data centres away from diesel generators, which is the go-to solution at the moment for standby power generation. So also Scotland is a leader in hydrogen and alternative fuel solution pilot schemes, and that should mean that those technologies will reach saturation and maturity faster in the Scottish region, meaning that they'll become available as solutions for data centres sooner. And then you have some of the obvious ones about Scotland's natural climate and geography. So there's a lower ambient temperature, relatively speaking, in Scotland. That offers great free cooling opportunities. You also have an abundance of high quality soft water, which offers adiabatic cooling solutions, which also leads to higher efficiency and lower PUE. And then of course you've got great availability of space. That space can lead to more efficient, less constrained designs. And the space can also be used for renewable deployments dedicated to data centres. So I think you see there's quite a lot of significant advantages to data centres, specifically in Scotland, for greenhouse gas reduction. So over to you, Kerr.
So just in summary, reduced greenhouse gas emissions can generate revenue opportunities, as well as coinciding with the reduction of the greenhouse gases. There's opportunities to satisfy those hyperscalers to meet their net zero targets of the future. Scotland as a whole has a lot of natural features and green infrastructure that can help support that moving forward. And most importantly, we as an industry, we need to change the way we're doing things to help reduce those greenhouse gas emissions, and things must change, and some things will definitely need to end for us to achieve that moving forward. And then just finally a little bit on i3 in terms of the differentiators between us and maybe some of the other consultancies out there. We're very client focused. We go that bit extra for clients typically. We provide independent resources. We don't fix ourselves on one specific manufacturer. We look at the whole market. We consider which is the best products for the designs that we implement. And at the core of it all, it's about making designs as efficient as possible, being as green as possible, and supporting our clients moving forward. So in terms of some of the clients that we've worked for, you can see on the right hand side there's some large clients that we've done a lot of work for, and we continue to do work for. And thanks very much, everyone.